In this lecture, we give two filtrations of the total complex, the vertical filtration and the horizontal filtration. So let us start with the vertical filtration. So the vertical filtration, it is written like this: Fn of tot of m, our total complex, and 1 denotes the vertical filtration, and in horizontal we will write 2 here. So this is obtained by deleting, so our filtration is obtained by deleting all terms to the right of column n and replacing them by 0. So for example, let us see this 1 of f3 of tot of m. So for this, after column 3, we are going to delete everything and put zeros here. So everything would be 0 here. So we put 0 everywhere after column 3. So everywhere is 0, is coming in from 0. So obviously this will contain naturally this column 2, because so this obviously contains our filtration 2, because filtration 2 means you are restricting yourself to this portion, and this everything else is 0. Now for the nth column, you take the nth part and you modulo out the n minus 1 part. So for example, if you want to talk about the third column, you will talk about this f3 and you modulo out our f2 of total complex. So f2 means that f2 just consists of this much portion. Everything else is 0. Everything else is 0 here. So when you modulo out like this, what you will get is just this column, and everything else would be 0. So once we modulo this second part out, the only thing you'll get is the third column. So this is the third column. As you can see, everything else becomes 0. So this is our associated graded module. So this is our associated graded module, is just the column. So our column is the associated graded module. And the anti-diagonal grading is inherited from the total complex. So even if zeros are not here, if you're just talking about, say, this portion, then again you can have the standard grading which we had in total complex. You just inherit from the total complex. And in case you have already modulo out the filtration 2 and you're sitting in this column, again you can isolate the individual modules by using grading on each column. So you know that this is grading 3 because 3 plus 0 is 3. So this is grading 3. This lies in grading 4. 3 plus 1 is 4. This lies in grading 5. 3 plus 2. This lies in grading 6. This lies in grading 7. So you can isolate such grading. So here we are talking about grading is this k, and n is our column. So here grading is 3. So 3 minus 3 gives you 0. Here grading is 4. So 4 minus 3 gives you 1. So grading is 5. 5 minus the column gives you 2. Here's the grading is 6. 6 minus the column gives you 3. So that's why we have n here, which is our column, and here is the second part. And so yeah, you can see the grading. So this is our column, and here you are putting the grading. So notice that once you modulo out in our associated graded module, the horizontal differential is 0 modulo the filtrations. You can't see any horizontal differentials. These are all delta 2 going to 0. These all deltas are going to 0. So only thing you're left is with these. So only thing you have is vertical filtration if you're looking at your associated graded module. So our differential, which was d plus delta in the total filtration, now in this associated graded part, it just becomes the vertical differential. Now this is very important. Sometimes in some lectures, in spectral sequences, you will say that, using vertical filtration, and when they say vertical filtration, they precisely means you're just considering the columns. You're just considering the columns. Either you can consider associated graded part like this, or you could just consider this total complex by itself, this initial part by itself. So you're just considering columns, and if these columns are exact, So if the columns are exact, you can immediately say the homology of vertical filtration is 0. So vertical filtration homology would be 0 if these vertical columns are exact. So vertical homology would be 0. Now if this vertical homology is 0, and if you already know about spectral sequences or you're going to learn about it, then you can say the final page which we denote as E infinity, this will just consist of 0 at every point. So if each of the vertical column is exact, then you know the final page just consists of the 0 modules. So if you know the final page just consists of 0 modules, you can say something about the horizontal differentials. So using vertical filtration, we were able to isolate the contribution of these vertical columns. So when we are talking about vertical filtration and we have isolated our graded modules like this is most likely the figure which we have in mind when we are talking about vertical filtration. So we do not have horizontal differentials in mind. So there might be cases when you have everything else beyond a column as 0, and then you're talking about both horizontal and vertical differentials. But most likely whenever people talk about vertical filtration, they mean some diagram like this. So this is in homology. In cohomology, the arrows would obviously reverse upwards, but here they are downwards. So this is the filtration which people have in mind, and the grading is inherited from the total complex. So this is our grading 0 part, and this is again our grading 1 part. This is again our grading 2 part, and then we have our grading 3 part, and so on. So again, notice that there are no horizontal maps here. So no horizontal differentials, and there are only vertical differentials are there. So if we are lucky, it could be the case that the green maps, they are not exact, but the vertical maps are exact. So if the vertical maps are exact complexes, if you compute the homology of this, you will just get zeros. So this is important. So there might be cases when you have horizontal maps as well, but whenever someone says vertical differentials, this is the figure which people have in mind. So this is the vertical differential. So analogously, we can define horizontal filtration. So now we talk about the horizontal filtration. So now we denote here 2 to distinguish it from the vertical filtration. So this is obtained by deleting all terms above a particular row n and replacing them by 0. So say we want to talk about this filtration 2f3 of tot of m. So that means above row 3 we will just put zeros. So this is it, and the grading remains the same, inherited from the total complex. So anti-diagonal grading. So you have the grading which is on the anti-diagonal, as we have seen before. This is inherited from the total complex, and you can isolate a particular row. You can isolate the nth row by modulo-iting the n minus 1 part. So from f3, if you modulo out f2, you get the third row. So if you modulo out f2, which will be just this portion and then zeros above it, you will just get this, precisely as in the vertical filtration. So let us modulo out this, so we will just get this row. So you just have the third row left now. Now you can talk about grading on each of the elements here. So the grading is k, and therefore you have to write k minus n plus n would be giving you k. So this is 0 plus 3, this is in grading 3. This is 3 plus 1, this is grading 4. So this 1 you get is from 4 minus 3, because grading is 4. So this is grading 5. 2 plus 3 is 5, but first element is just 5 minus 3. This is grading 6. First element k minus n we are saying is 6 minus 3. This is grading 7. 4 plus 3 is 7. So you can have individual grading on your modules. So again, if you modulo out like this in the associated module, so the vertical differential is now 0. So there is no vertical differential left, just going from 0 to 0. Only thing left is the horizontal maps, which are delta. So this differential d plus delta now just becomes d equals to delta. So in general, when people are talking about horizontal filtration, we are just assuming that only green arrows are remaining and there are no orange arrows. So this is how our horizontal filtration will look like. This is in 0. So this is in our grading 1, C1. This is our second grading. This is our third grading. And so on. So notice that there are no vertical differentials. So most likely there are not going to be any vertical differentials. And whenever someone says consider the vertical or the horizontal differential, they have either the vertical maps or the horizontal maps in mind. So this is a total complex for if you just have horizontal filtrations. So total complex obtained from horizontal filtration. So most likely it will not have any vertical maps. So both horizontal and vertical filtration help us isolate the complex into its individual pieces, either made up from horizontal rows or vertical columns.